Hello, I welcome you all in this presentation on the subject fundamentals of the manufacturing processes. Today's presentation on this subject is based on the classification of the manufacturing process, and this will have basically two aspects. One is the need to classify the manufacturing processes, and another is the different factors based on which we can classify the manufacturing processes. So, we will be starting with the need of classification, need to understand the classification of the manufacturing process. It basically involves in grouping the processes, grouping of processes based on some fundamental similarity, in nature. So, this is one that in which way we can put the different manufacturing processes in certain groups, like joining or the casting or the forming. So, they are grouped on the basis of a particular way or some kind of the similarity in the way material is processed for manufacturing process. So, this is the first we can see how the particular process is fundamentally similar to the other process or it is different in that way. This is one. The second is in developing the understanding on the process. It helps to us have the clear understanding on the subject or on the process to distinguish from other processes in light of the fundamental aspects associated with that particular process. Further, it helps to organize the processes in better way. Organization means since the processes are very large in number, so they can be grouped on their on the basis of their similarity of the certain features, and that in turn helps us in grouping, communicating, classifying the processes in a better way. Similarly, communication, effective communication of the processes, like the forming based processes are all those where some kind of deformation will be take place, or casting based processes where the melting of the metal will be involved, followed by the solidification into the mold to get the desired shape. So, the different category of the casting processes can be easily put together under the casting, and so we can easily communicate the meaning of the process by which the material will be processed or material will be treated in course of the manufacturing. Another purpose of the classification is that it will help us naming of either new processes based on their fundamental aspects and fundamental characteristics, or like based on the hybridization. Like if we are putting two processes together to have the better capability in terms of the, like say, shaping or providing the desired finish or controlling the dimensions more closely. So, that will help us in naming the newer processes which are being hybridized using two or more technologies, like say the laser beam can be used for assisting in deformation in along the particular region, or like the machining process may be clamped with the electrochemical action to increase the removal of the material, so that the desired surface desired dimensions in the component can be achieved. So, these are the things which can be achieved when the processes are grouped in the different categories, and this is what has been mentioned here. Like the grouping, to the need of the classification is to group the various manufacturing processes based on the fundamental similarity in their nature, to have the better understanding of each process based on their grouping, and to make an effective communication, or it makes the communication easier by having just one name of each process, like the sand mold casting or die casting or centrifugal casting, all those these are the processes which where the molten where the given material will be melted and then it will be processed into the mold to get the desired shape. However, the processing may be different, the approach of the processing during the casting may be different, but so that's why that's how the communication becomes easier when the processes are grouped based on their fundamental similarity, and it also helps to organize the information related to the manufacturing processes. For example, one particular product is to be made, then we can mention that first of all primary forming or primary shaping will be carried out using either casting followed by machining and then heat treatment. So, these are the three broad group of the processes. In casting, primary shape will be achieved, machining will help to achieve the desired dimensions and finish, and followed by heat treatment, that is another big group of the processes where desired combination of the properties will be achieved by altering the structure of the material in the solid state. So, this is what we can say as a purpose of the classification or need of classification. Now, we will see the different technical factors on the basis of which the manufacturing processes can be classified. So, we can say either criteria or the basis for classification of manufacturing process, classification of manufacturing processes. So, basic discipline and the manufacturing here, like if the chemicals are involved, it is a chemical industry, or the biotechnological technological aspects are involved, it is bioengineering, or if the nano technology for those processes or the which are using the nano features related with the production or the manufacturing of the goods, and similarly for electronics and the construction as per the kind of the basic discipline and the manufacturing process involved. Second is the material. The kind of material which is being used for processing purpose. So, here we will see if it is the metal or the polymer or it is the ceramic or composite. So, accordingly we name the process accordingly, like the kind of material being used for processing of the metallic materials involved in manufacturing, or the polymers are involved, ceramics or glasses, like the glass industry which is used for making the glass based products, or the composite processing, or the biomaterials like woodworking. So, the manufacturing process based on the material being used for processing can be grouped as a metal processing, polymer processing, ceramic processing, glass processing industry. And the next the factor is the extent of the automation. So, here what we can see, whether the industry or the given manufacturing unit uses the manpower for exerting the energy, exerting the force. So, like the mostly the controls are manual, or here the control is partial, manual control is partial. So, it becomes semi automatic or the fully automatic, where manual interactions or intervention is not much needed, only the raw stock is to be fed for ensuring that the process continues smoothly. So, in case of the manual, all relevant controls are achieved manually, and semi automatic, it requires a lot of the manual interventions or intervention of the human being to ensure the success of the process. And in case of the automatic, mainly the feeding of the raw material is ensured manually to see that the process goes on smoothly, or whenever it requires the intervention, it starts malfunctioning, then it needs the intervention of the human being to ensure that process is brought back into the action. Then the treatment, the way by which material is treated. So, the treatment of material. So, here basically this is another bigger classification of the process where the way by which material is treated. For example, mass conservation processes, So, there are two processes in this category. One is the forming, whether it is bulk forming or the sheet metal forming or the casting. In both the cases, what we do in case of the forming, the given volume of the material is taken, then using the force it is deformed as per the requirement. So, there is actually no loss of the material. So, this kind of shape may be achieved after the deformation. In this process, there is no loss of material, only the shifting of the material from one region to another region takes place. Similarly, in case of the casting, we take one amount of the raw material and then it is brought to the molten state, and then the same is poured into the mold to get the desired shape of the component. So, the product that we get, you see its shape, only shape is changed from the initial raw material, it is converted in the molten metal and then putting into the mold, the desired shape is achieved. So, technically there is no loss, however little loss may be involved, that material is getting lost in form of slag or in form of the impurities or oxidation, but those losses are very negligible. That is why the forming and casting, both these processes are put under the mass conservation or the zero processes, because there is no loss of the material, only the shifting of the material takes place from one region to another using the two different approaches. In one case the force is applied, and in another case the material is brought to the molten state. The second one is the positive process, wherein the desired size and shape is achieved with the addition of the material, like simpler shapes. If this is the one shape and this is the another, then two can be brought together through the joining processes, so that the desired one can be achieved. So, since the two members are brought together and then the metallic continuity or the joint is achieved between the two in order to get the desired size and shape. So, this kind of processes are known as the positive process, and under this category we have basically joining. Under the joining we have the welding, we have brazing, and we have soldering and adhesive joining. All these processes, in all these processes what we do, we try to bring the two components or two or more components together, so that the desired size and shape can be achieved. And the third one is the negative process. So, here we can say the positive process are addition processes, because things are brought together, and the negative processes or you can say subtractive processes. So, in case of the negative or subtractive processes, primarily we have machining. In case of the machining, we know that desired size and shape is achieved through the removal of the unwanted material from the stock or from the raw material. So, as I have said, this is the stock in the beginning, and if you have to achieve any particular shape like this, then whatever is the extra material, that needs to be removed. So, what we do, this material from this hatched region will be removed using a combination of the processes, combination of the machining processes, in order to achieve the desired shape which is to in the component which is to be made. So, since the removal of the unwanted extra material from the stock material is involved in this process, that is why this is called subtractive or the negative process. Basically this is the machining process. In machining again we have the two variants, one is the conventional machining and another is newer machining, or it is also called unconventional machining. So, unconventional machining is used for those which are very difficult to machine using the conventional machining methods. So, this grouping was based on the treatment of the material, like the addition of the material involving the joining processes, like here based on the whether we treat the material, how the work material is treated in course of the manufacturing, addition of the material is involved in joining, subtractive processes involving the removal of the material, like in machining, and the equivalence of the material which is involved like shifting of the material from one region to another, like in casting and the forming processes. Then coming to the another classification where the approach of treating the material, approach of treating the material. Approach of the treating material, there are 5 different categories, like the processes. I will explain this here itself. The processes based on the fluidity and solidification of the material, like all those processes in which the material is brought to the molten state, it is allowed to flow into the mold so that it occupies the shape which is to be made, and then subsequently solidification of the material results in the making of the component which is to be made. And this category of the processes are called like casting processes, and there are various casting processes which will be put under this category. Another process, another grouping is based on the processes which are based on the plastic flow of the material in solid state, and which are also involved with the elastic reactions, and where like say those processes where the plastic flow of the material using the external forces is achieved to get the desired size and shape, like in the forming processes of bulk material forming or of the sheet material forming, they will be placed in this group. Rolling, forging, extrusion, drying, deep drying, bending, etc., all those processes where this kind of the treatment or approach is involved. And then processes based on the joining of the solid component, like in this case what we do, the two members to be joined are the two members are brought together to get the desired size and shape in the component. So, this joining may be achieved through the fusion of the fang surfaces of the two components to be joined, or by just heating one of the components, heating the base metals, and by putting the low melting point material between the members to be joined, and thereby facilitating the joints. So, in case of the joining by melting of the fang surfaces, like fusion weld joint is achieved like this, and in case when the heating is involved of the edges of the members to be joined, followed by putting in the low melting point material between the fang surfaces, and the solidification results in the development of the joint in the processes like brazing and the soldering. So, this is like you say the fusion welding, and this is brazing and soldering. There is another category where just the plastic deformation of the material between the joint ensures the metallic continuity, and for this lot of mechanical action is used to ensure the flow of the material from one side to another, so that the two members to be joined can be brought close enough to each other, so that the metallurgical bond between them can be created. The processes based on the cutting, like the drilling, milling, machining, So, this is another group of the processes. The processes based on altering the microstructure, solid microstructure. So, this group of the processes is used for altering the properties of the material through the heat treatment approach. So, the basically the component whose properties are to be changed, they are heated to the high temperature, and then after soaking to the suitable time, it is cooled at a different rate in order to achieve the different set of the properties. So, basically this involves altering the microstructure in the solid state. It basically involves the heat treatment processes or the combined processes where the different approaches are used to get the desired size and shape, and the sintering is one of the examples. For example, like the combined processes where hybridization techniques are used. So, this hybridization may be involving one or more of the of these approaches to make the components. Now, coming to the another classification, the next classification is based on the user, who is the user of the product being made. So, based on this, there are two categories. One is the consumer goods, the products which are used by the public. So, the manufacturers will be making those products and they will be used by the consumers or by the public. So, they are termed as like the toothpaste or bicycles or cars, all these are the consumer goods, and the products or the machines, equipments, tools which are used for making the consumer goods are called capital goods. This is another one, capital goods. So, this is another grouping of the manufacturing process, the consumer goods industry or the capital goods industry. So, those which are making the machines, equipments to be used for further manufacturing of the consumer goods, they are termed as a capital goods industry, and the industry which will be making the products for use by the public will be falling under the consumer goods. So, this is what we can see, the based on the user we can put the things like consumer goods, car, pens, motorcycles, etc., and the capital goods which are to be further used to produce the consumer goods and the services. Based on the production strategy, like hard products where basically the job shops are used to make the customized products, and the soft products where the things are means the manufacturing system is designed in such a way that the raw material is used, takes the entry in the beginning, and at the end we get the finished product. So, there are various industries like the steel making industry, cement industry. These are the examples where the raw material enters in the initial stage and then comes out in the final form of the product to be used. So, depending upon the volume of the product to be produced, we can have the hard products or customized products which will be facilitating the requirement of the individuals, or the mass products. They will have all the products which are being made, they will have similar feature and it will be serving the demand of the so many people. Then based on the system organization, like this is another classification where the system organization with the emphasis on the final product, the discrete manufacturing and the continuous manufacturing. In case of the discrete manufacturing, a number of the separate operations is involved, and independent in the sense that these operations can be separated arbitrarily in the time and space. Means one product can be made at one time at one location, then the another product can be made another time at another location, then two can be brought together to assemble the things. So, the production of the toys, computers and cars is based on this kind of logic, where the different components can be made at the different locations and different times, then they will be brought together to be assembled, so that the desired final usable products can be made. The continuous process or continuous manufacturing, where the material, raw material is used in the enters in the beginning and then comes out in the form of final product at the end. So, there is a continuous flow of the material from beginning to end until it takes the final shape of the final product. And the examples of the continuous processing is like production of the bread or paper or the steel rolling, etc. Coming to the newer approaches, which will be involving the newer logics and newer approaches for the manufacturing, like the based on the some organizational logistic aspects for increasing the productivity and meeting the demand of the customers, like lean manufacturing, which is used for reducing the wastages related with, and the flexible manufacturing, which uses the robots or the automated guided vehicle or the CNC machines, all are interconnected with each other. It can be used for manufacturing the variety of the products in a smaller volume to satisfy the demand of the customized products. Just in time manufacturing is the inventory strategy, which helps to reduce the strain on the storage, and it helps to have something whenever it is needed for the purpose of the manufacturing. Agile manufacturing, it deals with the fast changing demands of the market, and bulk manufacturing is about the mass production. So, here I will now conclude this presentation. In this presentation, I have talked first about the need of the understanding the classification of the manufacturing processes, and thereafter the different technical factors on the basis of which manufacturing processes can be classified. Thank you for your attention.